Dear students, in this video we will discuss one more very important physical property of water, that is anomalous expansion. Expansion which is anomalous, not normal. Before going to this, let's recall the other very unique and different properties of water. Like water is the only substance that exists in solid, liquid and gaseous, all the three forms naturally on earth. Water is life. Without water, life cannot exist only. Water is universal solvent. It can dissolve almost every solid, liquid and gas, less or more, sooner or later. Also, water is very unique for having very high specific heat capacity, due to which it is very useful substance as a coolant and also as heating agent. Water's latent heat is also very high, due to which also it is very useful in some other way. We will discuss some time later. Right now we are going to discuss one very unique property of water, that is expansion on cooling and contraction on heating, which is just opposite to normal observation of normal things. You know, when substances are heated, then kinetic energy of the molecules increase. As a result, their intermolecular gap increases. As a result, they expand. Just opposite happens when they are cooled. If heat is taken away, kinetic energy of molecules decreases. Molecules come closer. As a result, volume of the substance decreases. They contract. When we talk about water, though water behaves normally between 100 degrees Celsius to 4 degrees Celsius, but it expands abnormally when water is cooled below 4 degrees Celsius. It means from 4 to 0 degrees Celsius. When water is cooled means when its heat is taken away. If we start cooling water of 100 degrees Celsius, then normal things happen. As its temperature decreases, so its volume also decreases. But when it reaches to 4 degrees Celsius, after this, if it is cooled, then it doesn't contract, rather it expands. So its behavior below 4 degrees Celsius is said to be anomalous expansion of water, because below 4 degrees Celsius, when it is cooled, then it expands rather than contracting. As a result, normally solid form of every substance is having highest density. Liquid form is having less density than solid form. If in liquid gold or if in liquid iron we put a piece of solid gold or solid iron, then it will sink down because of being more dense. But that doesn't happen in case of water. When water is cooled below 4 degrees Celsius, then it expands. As a result, density of water is not maximum in its solid form, that is ice. It is maximum at 4 degrees Celsius, which is 1 gram per cubic centimeter or centimeter cube. We can also say it to be 1 gram per ml, because volume of 1 milliliter is the same as of 1 cubic centimeter. When we cool it, then at 0 degrees Celsius water density is less than 1 gram. It is 0.99 gram per cubic centimeter. If water, it means liquid form. Liquid water of 0 degrees Celsius is further cooled, then ice of 0 degrees Celsius is formed. You know, at a particular temperature called freezing point, when heat is taken away, then temperature doesn't decrease, but the liquid form gets converted to solid form. So when it further cooled, then ice of 0 degrees Celsius, its density is even less. It is 0.91 gram per cubic centimeter. Due to this less density in comparison to density of water of 4 degrees Celsius only, ice floats on the surface of water. This is the water. Then icebergs or ice cubes will float on the water. You take some ice cubes out of freezer and put in a glass of water. What do you observe? Ice is floating on the surface of water. This abnormal happening happens because ice density is less than density of water due to anomalous expansion of water below 4 degrees Celsius. So that is the reason, as the density is 1/11th less than density of water, that's why when ice is put into the water, then 1/11th of volume of it remains above the water and 10/11th of the volume stay under the water while floating. I mean, if this is the volume of the ice cube and it is floating, then only 1/11th of its volume will be above water because its density is little less than water, not too much less than water. Children, this anomalous expansion of water is very useful for the life of aquatic animals, because you know aquatic animals breathe in water. They take the oxygen dissolved in water with the help of their lungs or other respiratory organs according to the species. So if the water gets frozen in the cold climate, in the certain part of our country as well, in the winter season, or in other countries where temperature goes much below than 0 degrees Celsius in the winter, or at north and south pole where throughout the year temperature is less than 0 degrees Celsius, how do aquatic animals survive? I mean fish or other. So they survive because of this anomalous expansion of water. How? Have a look at this diagram. Suppose this is a water body. So it may be very huge, but I am showing here a smaller one so that you can see the difference in the depth. When atmospheric temperature decreases in winter, then what happens? That, as you know, heat itself flows from higher to lower temperature. So water bodies keep losing their heat to atmosphere. As a result, a layer of ice is formed on the surface of water bodies. How layer of ice? Means a small amount, or whenever exchange of state takes place, all of a sudden the entire water will not get converted to steam if we are boiling it. In the same way, when freezing starts due to loss of temperature, then also the entire water will not get frozen at the same time. If you take out ice tray from the freezer sometime, then you see that its upper layer is having a thin ice layer, but the under one is still not frozen. Then we keep it inside the freezer further so that the entire water may get frozen. But that is a small amount. When we talk about the water bodies, several kilometers even maybe depth of that, then what happens? That the ice forms a layer on the upper surface, and because a small amount of water gets frozen and comes up because of being lighter, then more comes up because of being lighter. Soon a layer of ice is formed on the surface of water body. Then what happens? Ice is a bad conductor of heat. Just like pure water is a bad conductor of heat, ice is also a bad conductor of heat. So it is like that it is covered with a blanket of ice, and below one water is at different temperature. -1 degree Celsius, then below that -2 degrees Celsius, then below one -3 degrees Celsius, and at the bottom, near to the bottom, it is -4 degrees Celsius. Not minus. 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius and 4 degrees Celsius. It means top water is the coldest because ice formed a layer over it, and after that, because of being a blanket of bad conductor, now the underneath water is not losing any more heat to atmosphere. Atmospheric temperature may be -5 or maybe -10, but now ice, like a blanket, when you cover your body with a blanket, then your body heat is not lost to cold climate. Right? In the same way, a blanket of ice is on the surface of water body, maybe ocean, maybe river, then the underneath water is not getting cooled further. So underneath water is at a little higher temperature. Here 1 degree, then 2 degree, then 3, and the underneath one 4 degrees, because the most dense water is of 4 degrees Celsius. You know, when water lost a little bit heat, its density decreases. 3 degree one, so it is light above. Then 2 degree even less dense, so it is above. Then 1 degree even less dense, so even above this. And the least dense is ice, which is at the top. And once it is at the top, now no more heat of the atmosphere is lost by the water bodies. So at this 4 degrees Celsius, fish and other aquatic animals can stay and breathe themselves in the liquid water. If the entire water gets frozen, then they cannot breathe by the oxygen present in ice. So they will not be able to survive. That's all.